Hi guys. Uh, for my personal reason, I had no time to solve problems during the past 3 days. So let me start medium level problem from today. Okay, this is a problem with higher acceptance rate. So hope this gonna be very easy. This has very many likes, so let's start. Given the root of the binary search tree, return a balanced binary search tree with the same node value. There is more than one answer, return any of them. A binary search tree is balanced if the depth of two subtree of every node never differ by more than one. Okay. So this is binary search tree, and this is balanced binary search tree. Depth of the two subtree of every node never differs by more than one. What does this mean? So by looking at this, we have 1, 2, 3, 4, and then you can select the middle one, like 2, for example, and then so for example, so we have some tree like this, so there are many nodes here. So what you're gonna do is we're gonna select the middle and push, and then we're gonna select the middle in the left and then push, and then select the middle in the right and then push. That way this tree and this tree will be balanced. And the next thing we're gonna do is this middle. So by adding this node has 1 in the left but none in the right, but this is balanced. And then by adding this is balanced, and this subtree and this subtree is also balanced because the difference is only 1. So we need to find the middle one, and then we have to do some binary search. And so in this case, how big is this? And are these all integer? So this is 10,000. It's not very large. And then node value is larger than 1. So the next question is how can you get the median value? One of the way is that median value in the position. So is there any way to get the smallest value? And then, yeah, because if the question is input is this one, we don't know whether this one, the size of this one, and then the size of this one, right? So one way to do this is to store this into the array, everything into the array. So in that case, we have to make sure that the array elements are all solid. So that means this one, that means we have to do some in order traverse. So that way we can all see, we'll make the kind of array. And the next thing we can do is, I'm kind of wondering whether there is any way to utilize the input without using additional space. But seems like it is quite difficult. Okay, so let's use root. So say this is method 1, and then the vector, we really need a tree node. We can just use int v, and then push, and then in order v, and we'll get v, and then build. Right? So traverse in order. So and then tree node, so if now root, we don't need to add anything, return. If root left, then traverse in order to left, and v. And then here root is not null, so v dot root fell, right? then here right, okay. Yeah, so that's how we get V, and then we have to build the V. Build. So now build the balanced tree. Build balance BST. Okay, so gonna have build balance BST, and then V const. So so what we need is that 0 and then oh, not here, 0 and then V dot size -1. So here int start, and so if start end, then let's think about the base case later. Int mid start plus and the minus start divided by 2. This is middle. So here the case is like we have 3 nodes. Okay, we have four nodes, for example. So 0, 1, let's say we have 4 nodes, 0, 1, 2, 3. So middle here is this one divided by 2, so this one. And so in this case, what you're gonna do is we're gonna try to add this into the balance tree, and then add this into the balance tree, and then we're gonna do some next round, which is left is same but right is, in the case left will be same, because middle, I mean this is -1, so this means that left equals right. On the other hand, this side of y, so on this side now we have left is middle plus 1, which means that so left and middle is not the same, but left is right -1 in the case. So we need to consider this case and this case. And to build first here, let's say if root when there is only one element, this will be not, and this will be not. So in that case, you can just return root. And not so here now we know that balanced BST new tree node into the middle one. So we have to build this. Get this one. And then val mid val b dot mid. So auto point new and then we have to return root. And then the next thing we need to do is build the balanced BST. V what am I doing? So how to build middle, and then create this one, and then call this build, and then left tree. Build V start to same mid -1, and then right tree build mid +1 and end, right? So next thing we're gonna do is root L left L tree. Right tree. Something like this. And then if L start and a new null pointer. So if there's two, 3, then what will happen? For example, if this one middle is 0, so 0 middle is 0, so 0 will be made, and then middle will be less than 0. So in that case, like this, something like this. In the case, we can do this, and in this case, is this case. So I mean, if the next call is this, so now left and right are same. So this this node will be created and then returned, right? So by this, we can return balanced tree. So let's think about this case 1, 2, 3, 4. So here, traverse in order. So and then left is null actually. So we in place back into the 1, and then we go to this. Then here, next round, this is also null, so we add 2, 3 until 4. 4 added here. Left node and right node both are null, so this will not be called. So we will have 1, 2, 3, 4 in the vector. And then so we'll have 1, 2, 3, 4 in the vector, right? So in here, initially this is start and this is end, right? So start is not this, start is much smaller. So we will calculate mid. Start is currently 0, end is currently 3, and mid is 1. So this node, which is this 2, is created, and then somehow it gets the next thing, and then we'll get the return. So we will get this one, right? So by the way, in here, what happened is that start is now 0, mid is this one, but now -1 means, so inside this call, end is now 0, right? So this one. So start is 0, so 0 is this one. This node is returned for the left tree. And then here, what happens is that this 3, 4, so this is start now. So 2 is start. So in here now mid is so 0 1 2 3 2 3 5. So 5 9 5 divided by 2 is 2. So mid is 2, which is this value, right? So in here, so we're gonna create this 2. No, 3 here. And then left, right will be called. And left, mid minus 1 is now 1. So this is 1 and this is 2. So no pointer is returned. And then for this 3 3 will be returned, 3 3. So in this case, so we'll create this one, right? Use of undeclared item build balance. Build balance. Yeah. Accepted. Yeah, accepted. Is that it? Okay. So let's see some solutions. C++ solution. In order, pushback, yeah, the same algorithm. In order, then return another value. It's almost same. So the time complexity is first to build a vector. We need O of n. Traversal is O of n. And then the creation of binary search tree is also O of n. So in conclusion, O of n. So this is wow. Ooh. Pretty long memory of n. Good solution, but I don't think we can come up with this solution during the interview. DSW. Okay, the DSW algorithm is more complicated than recreating a balanced tree from a solid array. However, it does not require any extra memory as we manipulate existing code. The big plus if you know to store more than just an int. The idea is to convert the tree into a vine using left rotation and then balance it using a right rotation. Convert the initial tree into a vine by doing the right rotation. What is rotation? We flatten a tree into a linked list. Head is the former, blah blah blah. like this. So here, so I am 20. Okay, I know 17 is this. There was a problem like this, making a linked list, which was pretty difficult one. I didn't solve that because it looked scary. So rotate, what does that mean by rotate? Right, rotate. We flatten a tree into linear. Count the total number of nodes C and T. Calculate the height of the closest perfect balance tree. Calculate the number of nodes in the closest perfect balance tree. Calculate the number of nodes. Calculate the number of nodes. Left to rotate C and T minus M node to cover up the excess of node. Left to rotate. What does this left to rotate? Okay. The height of the closest perfect balance is 3 and it contains 7 nodes. So we initially perform 2 left rotation to cover up the excess. What does this mean? I don't understand. I don't understand that we perform 3 left rotation. I don't know. Do I have to know? This is the question. DW, DSW. Balance a tree globally. Someone wrote PhD degree with this. This is initial step of DSW. Okay, so let's say that 20 has left child. Yes. Right rotate, left child around TMP. Right rotate. What does that mean, right rotate? I don't know. Anyways, this works. This works. Cool. One thing I noticed that some people like this guy, I am kind of weak when I make a base case. So this guy has this, and then I have one more here. So if I remove this, what's gonna happen? Just think about that. So back to 1, 2, 3, 0, 1, 2, 3. So here, and then here, they are same. The mid is same. So tree will be created, and then next turn, next turn, for the left, this is true. For the right side, start will be bigger. It's always this case. Okay. That's pretty cool. We don't need this. Yeah. That's pretty cool. So what to remember? If we delete this, then everything will be this one. Concluded this one. Yeah, I think that's it. So thank you and have a nice day. Bye.